This section explains why the book installs a safety net before its real work begins. Refactoring without a safety net is vandalism, so this chapter builds the net first. The primitive is a self-testing suite, tests that check their own results and print only pass or fail. What it does is convert debugging from a search into a localization. A bug's cost is normally proportional to the amount of history you must scan to find it. Run the tests after every small change, and the suspect region collapses to only the code written since the last green run. That code is a few minutes old and still in your head. That is the whole move. It is a detector that bounds where the fault can hide, a weaker thing than a proof of correctness and a more useful one. Fowler's quiet inversion is this: you write tests in order to go faster. The common assumption that they slow you down is exactly what gets inverted. This section explains the fixed schema that turns the rest of the book into a catalog. You can look things up in. Everything after this is reference, not narrative, and the chapter's whole payload is that fixed schema, the thing that makes reference possible. Each refactoring gets 5 slots: name, sketch, motivation, mechanics, and examples. The name is the one that carries the weight. Fowler builds it first, because a named move becomes a unit of vocabulary, something you can think and speak with. The catalog's real product is a shared language rather than a list of steps. Mechanics and examples are the same transformation at 2 compression levels. Mechanics is a terse checklist for when you already know the move. Examples is the decompressed teaching version for when you do not. The safety invariant threads through both. Take the smallest step and test after each. This section explains the schema behind every entry that follows. Everything after this point is a lookup table, and the chapter's whole job is to declare that table schema. A refactoring becomes a reusable operation the moment it has a name. That is what builds a shared vocabulary. The other 4 slots, sketch, motivation, mechanics, and examples, only make the named thing findable and executable. The move that does the work lives in the mechanics. Steps are written as small as they can possibly be, with a test after each one, so the entry doubles as a checklist you trust when memory fails. The trickier the situation, the smaller the steps. The generative primitive is this: to catalog any skill, name it first, then decompose it into the smallest independently safe moves. The examples are laughably simple on purpose. Distraction is the enemy of a reference. Distraction is the enemy of a reference. This section explains the first set of refactorings and the shape they all share. The atom of refactoring is naming, and every atom ships with its inverse. Extract function pairs with inline function. Extract variable pairs with inline variable, paired moves of equal standing. You travel both directions freely because the behavior's standing. A good extraction is gated by one thing: the distance between intention and implementation. Size does not decide it. In Smalltalk, the method called highlight was a single line that called reverse, a name longer than its body, yet worth extracting because the what and the how stood far apart. From these name-giving atoms, you compose upward. Functions gather into a class, a transform, or sequential phases. Learn to reverse a move as fluently as to make it. That reversibility is what makes the catalog safe to wield. This section explains the single move that every refactoring in the opening set performs at a rising scale. Each one names a boundary and keeps the naming reversible. Extract. Function and inline function are inverses, and so are extract variable and inline variable. A fragment earns a name that says what it does while hiding how it does it. If the name fails to pay for itself, you invert the operation at no cost. Change. Function declaration renames the boundary itself. The larger moves, combine functions into class, combine functions into transform, and split phase are the same extraction composed upward, functions grouped, then grouped again into phases. The atom is the reversible boundary. The catalog is that atom iterated across scale, holding one invariant, the separation of intention from implementation. This section explains encapsulation, the first structural primitive of the chapter. Interpose a gate on every piece of state so nothing outside touches it directly, and the reach of any future change shrinks to what lies behind that gate. That is the whole chapter. Encapsulation means narrowing the surface across which one module can depend on another module's internals. The work it does is that narrowing of dependence, and privacy is that narrowing of dependence, and privacy is only a side effect. Fowler takes Parnas's rule, decompose a system by the secrets each module keeps, and makes data structures the paradigmatic secret. A record reached through methods can be renamed, split, or made computed rather than stored without any caller noticing. Here is the generative move you can now run on any construct. Find what callers currently know that they shouldn't need to, and route it through a single point you control. Every refactoring in the chapter is one instance of installing that point. This part explains the unifying idea behind a family of encapsulation refactorings. The starting point is Parnas's criterion. A module's worth is what it hides. Every refactoring gathered here is one move at a different scale. Each one interposes an interface between what is stored and what is used, so that a caller touches behavior, never representation. Encapsulate a variable, a record, a collection. Seat a field behind a getter and a setter. Hide one class's delegate behind another. Wrap an algorithm in a function. Once that boundary exists, the form behind it is free to vary. You can rename the field, compute instead of store, or substitute the algorithm with no caller the wiser. The chapter's unity is that structure at every size, from a primitive value up to a module, is a secret waiting for its successor. This section explains why moving code counts as its own kind of refactoring. Placement is a variable you choose. Earlier refactorings changed what elements are, creating them, deleting them, renaming them. This chapter changes where they live. One primitive sits underneath every move here, from move function, move field, and move statements, down to slide statements within a single body. An element belongs in the context whose elements it references most. Coupling dictates locality. Unmevial and no, you move a function toward the data and the callers it touches, because co-locating what changes together is exactly what modularity is, the ability to modify while understanding only a small part. And since your grasp of the coupling sharpens as you work, placement is never decided once. It is continuously re-minimized. The decision is reversible on purpose. The harder the core, the less it matters. The less it matters. This section explains what makes the placement refactorings a single family. Every refactoring before this one changed what elements are, whether you create them, rename them, or remove them inside a fixed home. This chapter changes where they live. Functions, fields, statements, and whole loops migrate between contexts. The generative primitive is that placement is a dependency claim. An element belongs where the things it touches already are, so you move it toward its references. Modularity is the invariant being maximized, minimize the cross-context links, and understanding any change stays local. Every operation here is the same act. Move function, move field, slide statements, split loop, even remove dead code. Each one pulls coupled things together and cuts away what couples to nothing. Predict the rest from that one rule. Couples to nothing. This section explains the 9th chapter, organizing data and its single governing rule. One name, one meaning. A variable reused for two purposes is called aliasing. Two distinct quantities collapse onto one symbol, so the reader can no longer tell which one is live where. Every refactoring in this chapter restores the injection from meanings back to names. Split. Variable gives each responsibility its own immutable binding. The Haggis variable ACK becomes primary acceleration, then a second accelerator. Rename variable fixes the label. Replace derived variable with query. Deletes a name whose value was never independent in the first place. The reference versus value pair is the same move at the level of identity. It asks one question: is this datum shared or copied? Organizing data means making the map from symbols to meanings, one to one, so that structure stops lying about what is shared. This section explains the structural primitive behind organizing data. A variable assigned twice means it carries two responsibilities, and one name pointing at two meanings is where bugs breed. That single diagnosis generates every refactoring in this chapter. Split. Variable cleaves the overloaded name so each use owns its own binding. The Haggis example uses a variable named ax set once for the first force and again for both forces together. Split variable turns it into two names, primary acceleration and secondary acceleration. Rename. Variable fixes the name once the split is done. Replace derived variable with query. Deletes a variable whose value is merely a computation held stale. The reference versus value pair addresses the same collision at the object level. Is shared identity meant here or a copied value? Organizing data reduces to one move. Restore one name, one meaning, so each binding denotes exactly one thing. This section explains how to simplify conditional logic at the structural level. A conditional fuses two things a reader must separate: which case holds and why the code cares. Fowler's chapter is one move repeated. Lift the discrimination out of the branch and give it a name so the why stops hiding inside the what. Decompose conditional names the test and each leg. Guard clauses turn nested preconditions into flat early exits. Replace conditional with polymorphism pushes the switch into the type system, letting dispatch replace the branch. Introduce special case gives null behavior instead of a check, deleting the conditional entirely. The primitive is this: a branch you can name is a branch you can often dissolve. The best conditional is the one made structural. The best conditional is the one made structural. The best conditional is the one made structural. This section explains why conditionals are the hardest part of a program to read and the single refactoring move that cleans them up. Conditionals carry a program's power and most of its opacity. The code states what it branches on while hiding why it branches. Every refactoring gathered here is the same move, Swap a fragment that says what for renamed. Call that says why. Decompose. Conditional names the test and each leg. Consolidate. Conditional expression fuses. Same result checks into one intent. Replace nested conditional with guard clauses. List pre-check handling out of the main path. Replace conditional with polymorphism. Lets the type dispatch where a switch once did. Introduce special case absorbs repeated. Null handling into an object. The chapter's thesis is one invariant. A well-refactored branch reads as a reason, and the mechanism recedes behind it. The purpose is anonymous, so name the purpose. This part explains what an API is, and the single move that governs every refactoring applied to it. An API is the seeing where two modules meet, and its whole job is to make a promise the caller can trust without reading the body. The generative move is command query separation. A function either changes state or reports it, never both. So anything that returns a value is safe to call anywhere. You can move it, repeat it, test it. Every refactoring in the chapter is one operation on that seeing. Split the query from the modifier. Decide what the caller must pass versus what the callee can fetch itself. Strip flag arguments that smuggle a second behavior through one door. Favor immutability. Reshape the boundary until intent shows and mechanism hides. From this, you predict the rest. Any seam that lies about its side effects wants splitting. D-effects want splitting. This section explains how a module's interface becomes an honest description of what its functions actually do. A module's interface is a promise about behavior. This chapter's single move is making the signature honest, so that you can predict what a function does to the world from how you call it. Every refactoring here separates two things that leak into each other. The first separation is what a function returns from what it changes. That is, separate query from modifier. A pure query is one you can call anywhere, reorder, and cache. The second separation is what varies by value from what varies by behavior. That is the pair. Parameterize function versus remove flag. The third separation is what the caller supplies from what the callee can derive. The exemplar is command. Query separation. A value returning function with no observable side effect is the joint you never have to worry about. This section covers the closing chapter on dealing with inheritance and its single thesis. Inheritance is a tool you spend once. It fixes a single classification axis at the moment of declaration, and its misuse only shows up in the rearview mirror. The thesis here is that irreversibility is an illusion of neglect. The structure itself never imposes it. Every refactoring in this chapter keeps the hierarchy reshapeable. You can slide members along it with pull up and push down. You can add or dissolve classes with extract superclass and collapse hierarchy. And when the axis you committed to stops fitting, you can exit inheritance entirely for delegation, with replace subclass with delegation, with replace subclass with delegation. The generative move is this. An is. A relationship feels like a permanent decree, but it is really a currently cheap coupling. You can refund the moment a second reason to vary appears. That refund is object composition, recovered from a subclass you already wrote. This section explains why inheritance in Fowler's final chapter becomes something you can always undo. Inheritance is a bet you can always unwind. Every refactoring in that closing chapter is reversible motion along two axes. A feature slides through the hierarchy. Pull-up method, push-down field, each carrying its literal inverse. Or the hierarchy itself grows and shrinks. Extract superclass against collapse. The binding surprise is that the axis runs past inheritance altogether. When the is a relation was the wrong tool, replace subclass with delegate converts it to has. So the book ends by dissolving its own final subject. Inheritance stops being the commitment you regret in the rearview mirror and becomes one placement among many, mechanically retreatable. Prefer composition ceases to be advice and becomes a sequence of safe, tested steps. Hierarchy is the final thing you learn to unfreeze.